Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to start new chapter today. Chapter's name is a CAM. So we already discussed this CAM and follower in our first chapter, simple mechanism, but we are going to study detailed CAM profile in this chapter. Okay, and in today's lecture we discuss the introduction to CAM and follower and types of CAMs and types of followers. So let's start. Okay, so first of all, what is a CAM and follower, how it is used, and what is the output of using this CAM and follower. So CAM is a rotating machine element which gives reciprocating or oscillating motion to another element. Means CAM is a rotary element which gives reciprocating motion. Means you can see here the roller is if this CAM is rotating in this direction, the follower will reciprocate. Okay, in this slot. Okay, there is a constrained direction is given to the follower, so it can reciprocate with respect to rotation of CAM. Okay, here for smoothness this roller is given which is also rotate. Okay, so check this. In roll this follower will reciprocate. And oscillatory motion means there are some types of CAM and follower arrangement are there in which the follower is oscillating. Okay, you can see here when this CAM is rotating, in this rotation rotary motion is translated into this oscillation of this follower, because this follower is moving with respect to this point. There is a turning pair, so with respect to that this follower will oscillate. Okay, with respect to rotation of CAM. So CAM is a rotary element which transmit the motion, means transmit the rotary motion into reciprocating or oscillating motion to another element. Okay, an element which is connected to CAM is known as a follower. Okay, so which is follower. So let's start the types of follower. This CAM is rotating, and with respect to that this follower will reciprocate. So you can see here the motion of the follower. As the CAM is rotating with respect to this profile, this follower is moving up and down, and there is a spring or sometimes there is a load, external load is given here, so that always between CAM and follower there will be some contact. So maybe there is some load or this type of spring is given, so CAM and follower kept in a contact, and this motion of this follower is totally depend upon this surface, means this profile which is known as a CAM profile. And in this chapter we are going to design the CAM, means this profile design is there in this chapter, CAM profile. Okay, so let's start the first of all we discuss the applications of this CAM and follower. You can check here the CAM and follower is widely used in an inlet and exhaust valve of internal combustion engines. Okay, you know that there is a camshaft. You can see here this is the camshaft, crankshaft is here, and rotate this inlet and exhaust valve totally depend on this camshaft, and camshaft operate the inlet and outlet valve. Okay, so camshaft is rotating by the crankshaft by this timing belt, and inlet and outlet valve is operated. So this is very important mechanism which is widely used, and also it is used in automatic automatic attachment of machinery. Okay, paper cutting machines, textile machines, and feedback mechanism and feed mechanisms of automotive lathes. It is also used in feed mechanisms of automatic lathes. Okay, so you can see here the paper cutting machine mechanism. In this you can check here, when this lever is pulled like this in this direction, this will force this body in this direction, and this follower, there is a follower is here which will move downward. Due to this cam, you can see there is a cam profile is here, and due to that this will move downward and cut the paper, you can see there. Okay, but when there is our output is done, paper is cut, this spring will force this total body to in its original condition in this direction, and lever will move automatically backward. Okay, so you can check here. So you can see here this reciprocating motion of this plate, and with respect to that, these two follower will cut the paper here. Okay, so this is the application of paper cutting machine, and this type of mechanism is widely used in lots of machines. Okay, so let's start the according types of follower. So first classification is based on the surface in contact, means which surface is touching or in contact with the follower. So first type of our classification is category of our classification for the follower is according to surface in contact. So first is a knife edge follower, and you can see here the knife edge means this surface is totally sharp. Okay, that's why it is known as a knife edge follower. At the end of follower there is a pointed surface is there, and there is a point contact between follower and cam and follower. Okay, there is a point contact is here. Okay, and there will be spring or load or anything can be here, so this follower kept always contact with this cam. Okay, next type in a surface contact is a roller follower. You can see here roller is there, and due to rotation of this cam, this follower will reciprocate. Okay, there is a less friction in a roller with respect to this knife edge, because you know that in roller is also rotating on its position, it is also rotating, and during the rotation or dynamic friction is always less than static friction. Okay, next type is a flat face follower. In flat face you can see a knife edge and roller, in place of there will be flat surface, you can see here. So what is the advantage of this flat face? Okay, we have the roller which gives less friction. So why we use this flat face? Because roller and knife edge have some limitations which is related to flat face. So the advantage of this flat face is it can work on very high pressure angle, because you don't know what is a pressure angle right now, because in next lecture we will study the terminology, but I can give you very basic example. If I am giving you one thing, this type of his cam is there, means oval shape is very high and it is rotating with his center, so it is rotating. Okay, so if I put some follower is here, one follower is here. Okay, consider it is a knife edge follower. So there is a possibility of this follower will jam at here, because this slope is very high. So in this condition, maybe this follower will not move upside and it will jam, because there is the shape of this cam is very oval. Okay, but in flat face the total cam is below this surface. Okay, so this type of flat face will give you working with a high pressure angle, so possibility of jamming this mechanism is very less. Fourth and last type of surface contact is a spherical face. Okay, which is same as a flat face, because you can see there is a flat face same, but it is a spherical shape is given, because in flat face you can use in flat face there is a high friction is there, so it is reduced by this spherical surface. So it has both advantage, less friction, less wear, plus it can work on a higher pressure angle. So second criteria for the classification of follower is based on motion. Which type of motion is there and how the follower is moving is a criteria for the classification. So first is a reciprocating, second is a oscillating. All example we have seen in a previous slides are reciprocating with respect to, you can see there. So this follower is a reciprocating with respect to cam, you can see that. But in oscillating, there is a one thing is there is a hinge point is always there, means this lever, you can say this lever is a hinge with some with respect to some point, and with respect to that there is a oscillating motion or rotary motion is there. Okay, you can see here, and there is always spring or load is given, so can follower and cam always kept in a contact. So this external force is always there, so this follower always touch with this cam. Okay, so this is the two types. Okay, one is a reciprocating and second is a oscillating or rotary. Okay, third criteria for the follower is a path of motion. First is a radial. In radial you can see that the motion of follower, this follower is moving here, so this motion of follower you can say here in this line. Okay, and it is always passed through the center of cam. You can see there is a cam and center of cam is here. Okay, and motion of follower you can see there. So this line of motion is always passed through the center of cam, then it is known as a radial. But when some followers are there which are eccentric, means there is a minor distance is there, you can see here the center line of this follower is here and center of this cam is here, so there is a eccentricity is there. Okay, this eccentricity due to offset is there, and that's why it is known as a offset follower, and if is passed through the center of cam, it is known as a radial follower.